iron metal can be produced from the reaction of iron ore with carbon monoxide. And we want to calculate delta H for this reaction using the following information. So we have three other reactions here, and we have their delta H values, their enthalpy values, and we want to calculate delta H for this reaction. So this is really a Hess's law problem. So Hess's law is what you use when you have a bunch of reactions and you want to use those reactions to calculate delta H for some other reaction. And this is just an exercise in kind of putting these in the right order to get this thing up here. And the rule is we can flip the reaction around, so I can change the direction. And if I do that, delta H changes sign. Or I can multiply a reaction by some constant, and if I do that, I have to multiply delta H by the same constant. So basically, whatever you do to a reaction, you got to do the same thing to the delta H value. Okay, before we do this, incidentally, what are the names of all of these things? We have FeO, we have Fe2O3, and we have Fe3O4. Well, I know the oxidation state of oxygen is -2, and so this must have an oxidation state of +2 to balance. So this must be iron 2 oxide. Okay, makes sense. How about this one? Well, if oxygen has an oxidation state of -2 and there's 3 of them, that makes a total of -6. And to make a +6 over here, to get a +6, I would need iron to have an oxidation state of +3. +3 times 2 would give me +6. So this must be iron 3 oxide. Okay, what's this last one? So in this case, if oxygen has an oxidation state of -2, this would be a -8. What's this going to be? Well, that's kind of weird. Let's see. I would have 3 times something plus 4 times -2 would have to give me 0 in order for this to balance. And so that means that 3x would have to equal 8, which means that x would have to be 8/3. Well, that doesn't sound right. So this is kind of an unusual compound. This is actually, if you were to name it, iron 2, 3 oxide. So what's going on? It's actually that the iron is made up of a combination of Fe2+ ions and Fe3+ ions. So it's kind of a mixture of both of them, and so that's why we have the 2, 3 here. That's kind of a weird one. Not something that I would expect that you would know offhand, but it's kind of interesting. So these are the 3 compounds that we have here with iron. Okay, now let's solve the problem. So to solve this, I'm going to look at the 3 equations and see if I can put them in the right order. Now, I recommend avoiding the carbon monoxide and the carbon dioxide until the very end, because they're in all 3 equations, and that's going to be kind of hard to work with. Instead, just look at the stuff that appears only once down here. So for instance, this FeO, I want to find that. That is right here. It's in the 3rd equation. In fact, let's number these. So let's call this equation 1, equation 2, and equation 3. Okay, so the 3rd equation, but it's on the wrong side. So I want to flip it. So let's flip equation 3 around. So that'll be 3 FeO solid plus CO2 gas is going to give me Fe3O4 solid plus CO gas. And if I do that, the delta H value also has to be flipped. So now it's going to be negative 18 kilojoules. Okay, now what? So I have FeO, but I introduced this Fe3O4, and that's not on this side of the equation at all that I want. So I'm going to have to cancel it by putting it over on this side. And if I look over here, I see equation 1 has it, but it's on the wrong side again. So let's flip equation 1. So if I flip equation 1, I'm going to get 2 Fe3O4 solid plus carbon dioxide gas. It's going to give me 3 Fe2O3 solid plus carbon monoxide gas. And again, I got to flip the delta H value. So it was negative 39 kilojoules. Now it's going to be positive 39 kilojoules. All right, now what? So I have Fe3O4 here. I have 2 Fe3O4 here. So I'm probably going to have to multiply equation 3 up top, this one here, by 2. So if I do that, I'm going to take the equation 3 that I had flipped, and I'm going to multiply that one by 2. So this is going to become 6 FeO solid plus 2 carbon dioxide gas. It's going to give me 2 Fe3O4 solid plus 2 carbon monoxide gas. And since I multiplied this by 2, I'm going to have to multiply this negative 18 by 2 as well. So that's going to be negative 36 kilojoules. Okay. Now what? So I have the Fe3O4 canceling here and here, but I still don't yet have the iron metal. And I see that in equation 2. It's right here. So I want equation 2, but I see also that I have Fe2O3. Fe2O3 is right here. That's going to have to cancel, and there's 3 of them. So I'm going to want equation 2, but I'm going to multiply it by 3. So I'm going to take equation 2. I'm not going to flip it, but I am going to multiply it by 3. So I'm going to get 3 Fe2O3 solid plus 9 carbon monoxide gas is going to give me 6 iron metal plus 9 carbon dioxide gas. And for the delta H, since I multiplied this equation by 3, I have to multiply this negative 23 kilojoules by 3, and I'll get negative 69 kilojoules. Okay, I think we have our net reaction. Let's take a look and see. So this top one here, I actually turned it into this one. So let's get rid of that. We're not using that one anymore. And let's look at these 3 right here. So in this case, for the net reaction, I have, let's see, Fe3O4 and Fe3O4 cancel. Those are gone. Fe2O3 solid and Fe2O3 solid, those are gone. So FeO solid, I do have that, but I have 6 of them. So 6 FeO solid. Okay, took care of that. Plus, let's see, carbon monoxide. Let's see, I have 9 carbon monoxides here, and I have 3 here, 2 here and 1 here. So that's going to leave 6 on this side. So I have 6 carbon monoxide gases. Okay, took care of those. Now what? Iron metal is next. Iron metal is only right here. I have 6 of them. Okay, took care of that. And last we have carbon dioxide. I have 3 on this side. I have 9 on this side. So that is a total of 6, and I think that's everything. And so now for the delta H's, I can add these values up. So I do 39 kilojoules minus 36 kilojoules minus 69 kilojoules, and you get negative 66 kilojoules. Okay, but this is not quite the reaction I wanted. If you notice, I don't have these 6's as coefficients up here, but that's easy to take care of. If I have a 6 in front of everything, to get the reaction I want, I can just divide everything by 6. So in that case, my delta H is going to be negative 66 kilojoules divided by 6, or negative 11 kilojoules. And that's your final answer.